Here we go, guys. An equation involving a derivative is called a differential equation. Oh, yeah. When you guys get to the university, there is a class just on differential equations alone. What is it called? Differential equations. That's the name of the class. I'm not kidding. You math majors, physics majors, engineers, maybe possible future doctors, I'm not sure, but engineers for sure, and physics majors and math majors, you're going to have to take a class called differential equations. You take it after you take Cal 2, and many times some universities make it after Cal 3. We are going to be dealing with first order differential equations. We're not going to be doing the advanced ones, the fancy ones. The order of a differential equation is the order of the highest derivative involved in the equation. When you take DPQ, you're going to be dealing with third order, fourth order differential, non-homogeneous equations. Oh wait, I think they're homogeneous equations. We'll let the professor take care of those. We're just going to be dealing with simple ones. All right, here we go. You've already been doing this. Okay, is this up there? Yeah. You've already been doing this. No, nothing crazy. It says find all functions y that satisfy this equation. All you got to do is take antiderivative, guys. Y equals antiderivative of secant squared is 10x plus antiderivative of 2x is x squared. You can say 2x squared over 2, but hopefully by now we're already starting to just be able to do it. Antiderivative of 5 is 5x, and don't forget the c. Some professors make you write for some constant c, some of them don't. Whatever your professor tells you, do that. I'm okay with this. I know that c is a constant. We're done. That's it. Check mark. So sometimes they give you an initial value. So these are the ones, this is what Godinez wrote. Godinez did this. All right. So sometimes they give you an initial point or some type of initial statement. So it says find the particular solution. Again, we're doing the same thing, guys. Y equals antiderivative of e to the x is e to the x minus antiderivative of 6x squared. Well, let's see. Add 1, divide by that. 6 divided by 3 is? So I'm going to write 2x cubed plus c. And then since I got an initial statement here, or I got a point, 1, 0, I can just plug in. 0 equals e to the 1 minus 2 times 1 cubed plus c. Getting c by itself, moving everything to the right or to the left there. C is equal to, let's see, 2 minus e. So what do I have? My equation is going to be y equals e to the x minus 2x cubed plus 2 minus e. Hopefully I didn't make any mistakes there. And that's it. That's my equation. How do we feel so far? Okay, everyone looks like we're good to go. All right, here we go. Here's the fun stuff. These are the questions that we missed on the AP exam, on the mock exam, the first one. Separable differential equations. Not every differential equation is separable. Make sure you know that. Maybe that's something we should put. Not every diff EQ. This is how you abbreviate differential equations. Not every diff EQ is separable. Some are. A differential equation in the form of dy dx equals f of y g of x, notice that y here, is called separable. We separate the variables, we're writing it in the form. All they did was they put the y's to the left and the x's to the right. The solution is found by anti-differentiating, that means taking an antiderivative, with respect to its thusly isolated variable. Obviously, I don't talk like that, so I must have stolen this from Demana. So I'm going to go ahead and quote it, Demana. That's a textbook. Demana. I just don't remember the page number. All right, so all that means, all that little paragraph means, get the y's together, get the x's together. That's all it means. If possible. Not all of them is possible, guys, not all of them. But all these examples, obviously we're rookies, we're starting with this. All of these examples are going to be separable. So how do you do it? When you get the AP exam, or any exam, not just the AP exam, this is how you do it, guys. It says solve for y, and they give me this 1, 1. So here's a point. So here we go. I'm going to get my equation by itself. First, I use my law of exponents. So dy dx is equal to x squared, y squared. You have to be pretty good at algebra, guys. Now, from there, I'm going to get all the y's to the left, all the x's to the right. So I'm going to write dy over y squared equals x squared dx. Does everyone know what I did? I had to divide by y squared to get it to the left. So here we go. I'm going to rewrite it. And I'm going to rewrite it again. Is everyone okay with where we are at right now? Okay. Give me about 1 minute. Do not write anything. I will give you time. Do not write anything after this. So here comes the big dilemma here. In order to get rid of the dy and dx, I'm going to have to integrate. And you are right, because we've told you anytime there's no limits, don't write anything down right now. Because we told you there's no limits, you are supposed to be doing negative y to negative 1 plus c. I'm going to put a 1 there, equals x cubed over 3 plus c. And those are constants. Don't write this down, just listen. And if I want to get the constants to one side, I can go minus c1, minus c1. Well, c2 minus c1, that is still some constant. Does that make sense to you guys? That it's still some constant. So the common practice is that we don't write C1 and C2, we just write a plus C on one side. On what side do we usually do it on? For the X. So usually you just go negative y to negative 1, that comes from antiderivative, equals x cubed over 3 plus C, because that is still just some constant. Does that make sense, guys? Okay, go ahead and write what we just did, or what we just talked about. I like to solve for C right here. A lot of professors are going to tell you to get y by itself and then solve for C, and that is okay. I like to solve it here because I think it's the easiest here. That's just my opinion. Everyone's opinion is going to be different, guys. Your habits do not have to be my habits. Are we clear about that? Okay. I like to solve for it here. Chavez, why do you like to solve for C here? Because here's where I am. Like, this is the first step I did when I did antiderivative, and I like to solve for C immediately. So I'm going to go ahead and rewrite it. Negative 1 over y equals x cubed over 3 plus c, and I'm going to solve for c immediately. I plug in my points. So negative 1 divided by 1 is just negative 1, equals 1 cubed, that's just 1, so 1/3 plus c. I move the 1/3 to the other side, so c equals negative 1 minus 1/3, which I believe, let's see, negative 3, that's a negative 4/3. Ooh, am I going to have enough space? I think so. I'm going to write here in the middle, guys. I think I have enough space. That number is that number, so I'm going to come to this one because that's the initial equation that I had. And here we go. I'm writing it here in the middle. Negative 1 over y equals x cubed over 3 minus 4 over 3. I have the same common denominators. Negative 1 over y equals x cubed minus 4 all over 3. Now I'm just doing algebra, guys. I don't want that negative in front of the 1 there, so I'm just going to move it to the other side. 1 over y is equal to a negative, and then x cubed minus 4 over 3. If you want to put the negative with the 3, that's fine. And now I'm just going to flip it. Y equals negative 3 over x cubed minus 4. And there it is. There's my equation. How do we feel, guys? Yeah, the algebra is a pickle. The algebra is the hard part, not the calculus. The algebra is the hard part, guys. All right, let's go to the next one. So how did it look? As you can see, don't worry, I have not assigned that UH quiz yet because I know that we got a lot of stuff to get done. But as you can see, you can already see the next UH quiz that we're going to set loose. So it says, use integration to find the general solution to the differential equation. Okay, before I do anything, I would just distribute, guys. dy dx equals 4x squared minus 4x. Times it by dx. So dy equals 4x squared minus 4x. Yes, I know it's all that times dx if you want to be proper. It's okay if you don't write the parentheses, but there it is in the proper way. And then what do I do to get rid of the dy and dx? I just do a what? An antiderivative. That will get rid of the dy and dx because of FTOC. So this just turns into y equals 4x cubed over 3 minus 4x squared over 2, which is 2x squared, plus c. And I look for that answer. And there it is. Yay. Math life. There's a little happy face with hairs going up like that. I don't know. Maybe you want to add curly hair. Or maybe you're like, this is math class and you shouldn't be drawing. Like, okay, sorry. I got a D in art. So, all right, here's this next one, guys. Use integration to find the general solution. Again, it's the same thing. Let's see, what am I going to do? Times y plus 5 times dx. So here's what you're going to have. Y plus 5, put the dy in the end. Don't write dy times y plus 5. And then write x minus 3, put the dx in the end. If you don't want to put parentheses, that's fine. Yeah, this is not like super exciting because it's like, you know, pretty general stuff. And then you just take the antiderivative of that dude. Let's see, y squared over 2 plus 5y. Chavez told me not to add the c here. He told me to add it to the x's. X squared over 2 minus 3x plus c. There it is. I start looking for that, and I start noticing that none of these have, look, none of them have it in, oh, I'm not saying that's the answer. None of them have fractions. I'm going to multiply everything by 2. Multiply everything by 2. By the way, if you multiply a constant, it's still a constant. So you're not going to say 2c, you're just going to say c. And I know that can be hard because all your life you've been told x times 2 is 2x. That's just a constant, guys. So a constant times 2 is still a constant. So I'm multiplying everything by 2. Y squared plus 10y equals x squared minus 6x plus c. And I see that everything says equals c, so I'm just going to move these two dudes to the left. And let's see what we have now. Do I have enough room? Can I write it down here? Y squared plus 10y minus x squared plus 6x equals c. And I look for that. Definitely not A. Definitely not B, because I have a negative x squared plus y squared plus 6x plus 10y. There it is. What do you guys think? Pretty easy, guys? All right. Should we skip this one or okay, let's not skip it. No. Again, get the y's together, get the x's together. So dy over secant y equals 1 over x minus 3 squared dx. If you want to do u substitution, you can. I don't think you need it though. Oh man, Chavez, what do I do with that secant? Well, I see a 1 over secant. Here comes your pre-cal, not extreme. 1 over secant is the same thing as what? Yeah, cosine. Cosine y dy. And this one just stays like this. If you want, you can put the dx on the top. You don't need u substitution on the right hand side, guys. I would hope that you can do it without it. Here we go. Integral. Antiderivative of cosine y is sine y. And look, you don't need it, guys. This is like same thing as saying, it's like saying u to the negative 2. Antiderivative, u to the negative 1 divided by negative 1. So negative 1 over x minus 3, and then put the plus c. If I were to do u sub, I would have gone u equals x minus 3. So I would have had this. I would have had 1 over u squared. See? You know what I mean? Oh, remember that's u to the negative 2. So we add 1 and then divide by that number for antiderivative. So u negative 2 plus 1 is negative 1. Okay. And we look for that answer, and Here it is, guys. Okay, we're done. That's all there is to it. And I was going to stop there for the lesson, but I decided to add this one because it's not that hard. By the way, this is all you're doing today on Delta Math, just this stuff. Okay, I'm not asking these questions just yet on Delta Math. I will eventually. Let's read this together, guys. Law of exponential change. You have probably solved enough exponential growth problems by now to recognize that they involve growth in which the rate of change is proportional to the amount present. The more bacteria in the dish, the faster they multiply. The more radioactive material present, the faster it decays. The greater your bank account, assuming it earns compounded interest, the faster it grows. Yay! That's actually a very good thing, guys. If you can start investing now, please start investing now. I'm being serious. If you can open up a Roth IRA, do it. If you can't, well, then don't, because you don't have money. But if you have money, start investing now, guys. The differential equation that describes this growth is that guy. Put a star next to it. That's super important. Where K is the growth constant if positive or decay constant if negative. We can solve this equation by separating the variables. The man of third edition, look, I went ahead and noted that one. Yay. All right, guys, you don't understand how powerful this formula is. This formula is in chemistry, in algebra. Do you guys remember the principal formula? The amount that you have in the bank is the initial amount invested, e to the rate times time. That comes from this. That comes from this. In chemistry, the half-life formula comes from this. Let me show you what I'm talking about. So let's see. I have dy dt equals ky, and I never remember the if negative and positive. I just let the situation tell me whether I get a positive or negative. So look, dy dt equals ky. All I'm going to do, I'm going to get the y by itself, and I'm going to multiply by dt. So dy over y equals k dt. I'm going to go ahead and rewrite it so it looks familiar to you. 1 over y dy equals k dt. Now I'm ready. I'm ready to integrate. Integral. Antiderivative of 1 over y. Do you guys remember? Perfect. ln. Absolute value, because there's no limits, equals k, and then, well, I'm going to put a t next to it, plus c. Now, there's an equation, but you don't want to have it like this, guys. You want to have it in terms of y equals. So to get y by itself, I'm going to go e. So now I have absolute value of y equals e to the kt plus c. Now here's a side note. All the whole thing. Here's a side note, guys. Hopefully you guys remember from your algebra days. E to the kt plus c, that's the whole thing up there, is the same thing as e to the kt times e to the c. And e to the c is just some constant. So I can rewrite this as y. Notice that I dropped the absolute value, equals c e to the kt. Why did I drop the absolute value? Let c absorb the absolute. Chavez, what does that even mean? It means that the problem will determine if c is positive or negative. Same thing with the k. We'll let the situation determine whether the k is positive or negative. I never remember, oh, it's positive, it's growing. I just, based off the situation, you'll see. And you're gonna see some awesome math magic. Well, it's not magic. Hopefully you'll love it. All right, you're gonna need your calculators, guys. Take out your calculators. I'll take out my calculator as well. How do I get it? OneDrive. Desktop. Come on, buddy. Desktop. Emulator. There we go. Okay, I got my calculator for the future. And then they give you this. Look, that really is the PERT formula, guys. You can change the Y naught to P, and you can change the K to an R. Let's read this. Oh, wow, it's a lot, Chavez. I don't know if I want to. Okay, let's read it together silently. Like 1 minute real quick. All right, read that, guys. Wow, that was very powerful, guys. I don't know if you guys read it or not. I hope you did. There's only 3 types of, okay, don't quote me because I don't have a doctorate in chemistry, but there's only 3 types of radioactive. There's alpha decay, 4, 2, like 4 protons, 2, something math. I don't know. There's beta. I'm not a chemist, guys. And there's gamma, but I'm not sure how the gamma works. I think these are the 2 that they test you guys in high school chemistry and university freshman chemistry. Alpha and beta. And if you want to Google to find out more about that or talk to Ms. Clark Rankin about alpha decay and beta decay, you can. All right, so this one says, find the half-life of radioactive substance with decay equation. And I have an equation here, they give it to me. And remember, the only reason why this works this way is because of this guy, that it decays with the amount proportional that is there. And show that the half-life depends only on K. Okay, so they want me to solve for T. Solve for T. And see that when I solve for T, it only depends on K. What's up? Yes. So the question says, find the half-life radioactive substance with decay equation, this equation, and show that the half-life depends only on K. So what they're telling me is, find my half-life. I'm going to put half there. That means half-life. And then show that whatever I have here, it only depends on K, that I have a constant with a K. K is some special number that determines how fast or how slow it's decaying, because it's an exponential. All exponential functions look like this, or like this. So K will determine how fast it goes up or how fast it goes down. So don't worry, guys. AP Calculus will never give you this question. I just put it in here because I want you guys to see how beautiful it is. So look how beautiful this is, guys. So if it only depends, if I have half of something, there's the initial amount. Initial amount. It's usually called Y naught. Why not? Why not? Okay, I'll stop. It's the Y and then the little 0 there is a naught. It's called a naught. So here we go. If I have half of that amount, of the initial amount, I'm gonna solve for T and see if it's only if only there's a K with a constant in it. So let's see, the Y naughts cancel out immediately. See, bam, bam. Oh, yes. I'm looking for the half-life, right? So if I have half of something, half, like this is the initial amount. And if I want half of the initial amount, this is half times the initial amount. Y naught is the initial amount. And half times Y naught will give me the half the amount. Does that make sense? Because I'm multiplying by half. Okay. And so now I just have this, guys. 1/2 equals e to the negative kt. And then what I'm trying to do is I want to bring those down, the negative kt down. So all I got to do is put a what on both sides? An ln. When I do that, I'm going to have ln of half equals negative kt. And look at that. I'm just going to divide by negative k. And there it is. Well, I'm going to write it better because this is probably not the formula you see in the textbooks. So ln of a half divided by negative k. But the formula that you see on the textbooks is not ln of a half, it's ln of 2. So how do we get that? Well, ln of half is the same thing as saying ln of 1 minus ln of 2. And hopefully you remember that ln of 1 is 0. And I'm going to put the half there because that means it is a half-life. So negative ln of 2 divided by negative k is just ln of 2 divided by k. So yeah, they're right. It only depends on k. I never memorize this, guys. But if you're in chemistry, you'll probably will. K is a value that they got to give you based off of the element, what type you have, carbon 14, carbon 6, carbon 12. Cool or not cool? Oh, you don't like it. Okay, no, don't worry. I'm going to help you on this. You know what? Let's do example 9 first before we do example 8. So go to the last page. All right. Scientists who use carbon-14 dating use 5,700 years for its half-life. So this is my half-life. Find the age of the sample in which 10% of the radioactive nuclei originally present have decayed. Okay, I could use this formula that I just learned, but I never memorize stuff. So because it decays to the proportional amount present, I can use this formula. Are we cool with that, guys? Or no? We're only using this formula because it decays proportional to the amount present. First, solve for k. First, solve for k. And I could use the formula that I just learned, k equals ln2 divided by your half-life, which they give me. But I know I don't even bother, guys. So here we go. I'm going to say half, why not, equals why not. And I know it's decaying, and I should put a negative. I'm stubborn. I'm going to leave it e to the 5,000, what was it?
Wait, why are we solving for k?
I'm over here. Sorry, guys. I need my k value to solve for the amount that I have. 5,000. K is the constant that will determine how fast or how slow something is growing. Because once I have K, I can just solve for T.
Oh, so we're looking for the equation.
Yes. I don't know T. No, how much time, I know the half-life for T, but I don't know how much time it takes for me to have 90% of the nuclei present. Should no? Okay, let's start again, guys. Let's start again.
I don't know because that means like if you have half your initial amount, then you have the half-life for T.
Correct.
Why can't we just use the formula we already found?
Because I don't memorize it. I want to show you that it works all the time, no matter what.
Well, we're gonna find it again.
Yeah, but in the UH quiz, you're going to be asked about population. Mm-hmm. And it's not going to be a half-life. It's going to be like populations.
I thought that this was just like fun things to learn, not like.
This is how hard as it gets. This is a differential equation.
I have a question.
Yes.
If they give us that number, and that's the half-life, if you spend
Mm-hmm.
why can't we do multiply by times 2? Wait.
I'm listening.
And then, like, because it doesn't give us how much we started with. Is that right?
Correct. Well, we know that we started with a full amount, but it wants to know how long did it take for me to have 90%. Because
So why don't we just take that number, multiply it by 2, divide by 10, and then multiply by 9?
I don't think that will work. Because try it out and see if you get it, but it doesn't seem logical to me. This is a half-life. It takes 5,700 years for you to have half of it. So how long will it take for me to have 90% of it?
Because the half-life, like, once you have that, then it's a different time for another half of that.
Mm-hmm.
That's what I'm saying.
All right, so let's time out, guys. Let's regroup about this. All right, so we have something that's decaying. And I hope we have enough experience. Hopefully you did this in chemistry, and it's okay if you didn't. Something's decaying, guys, like so. Are we okay or no? So I want to try to find out, this equation, by the way, is y equals y naught e to the kt. And yes, I know that it should be negative, but I always let a problem give me the answer. So when I solve for k, I'm going to get a negative anyways. Does that make sense to you guys? The question says, find the age of the sample in which 10% of the radioactive nuclei originally present have decayed. So if 10% has decayed, that means you have 90% left. Does that make sense, guys? Okay, so I want to know how long it takes for me to have 90% of it. It's obviously going to be a lot less than 5,700 years because that's how much it takes for you to have half. So here we go. I solve for k first. Solve for k. This is the equation. What equation am I using? I'm just using this one. I'm just using that one, guys. The only reason we can use that is because of this. dy dt equals ky. So then from there, the y naughts cancel out. I have 1/2 equals e to the 5,700k. What am I going to use? ln of a half equals 5,700k. Divide by 5,700, and I'm going to store this in the calculator. K equals, and here we go. I'm going to take out my calculator so everyone can see. So here's my calculator, and let me share it with everyone.
So when you explain why you did, I know you put a half there because that's the half left.
Mhm.
So we'll have half of the amount left.
Perfect. So Godinez is asking why I put a half in front of the why not. I'm looking for the k value when I have half the amount. So this k value is going to be specific to the half-life. Does that make sense?
And the K value is
How-
what's the rate?
Yeah, it's going to tell me how my curve, how fast I'm either decaying or growing. It's going to be negative, obviously, because I'm decaying. So check it out. I'm going to type ln, and I'm going to put 0.5, and I'm going to divide that by 5,700. I'm going to push enter, and that should be no surprise to anyone that it is negative. By the way, that e to the negative 4 means that it's really small. So that means negative 0.0001. Negative 0.0001 to, and I already forgot the number, 216. Store it to k in the calculator. So take my calculator back. So how do I store it? I push the store button and push alpha k. So there it is. It's stored in my calculator. I'm done, guys. I'm pretty much done. All you got to do now is this. I want to have 90%. So here we go. 0.9 of y naught equals y naught e to the k t. And this k value is stored in calculator. Stored in calculator. Remember, we got a negative value, which is not a surprise because it was decaying. Are we still okay? All right. Y naughts cancel out. All I'm doing is solving for t, guys. 0.9 equals e to the kt. And again, I'm going to do the same thing again. ln on both sides. ln. ln of 0.9 equals kt. And now I'm just going to divide by k. And t equals, and I take my calculator. So let's take my calculator. I'm going to move it over here. And look, I'm just going to type ln of 0.9. And I guess I didn't need to save it in k because it's the last number I had there. Divided by alpha k. Enter. 866.417 if you truncate it, or 418 if you round it. 866.417 years. And there it is, guys. How do we feel?
Where did the 0.9 come from again?
Oh, yeah. That's a good question, miss. Right here, it says find the age of the sample in which 10% of the radioactive nuclei originally present have decayed. So remember that my equation tells me how much I have. So if 10% has decayed, that means I have 90% because 10% decayed. Does that make sense or no? Yeah, so we have to take that into account, guys. This equation tells you how much you have. I suppose you could work backwards, but you'd have to mess around with some other stuff. How do we feel? Do we feel okay? Okay. Because we've been working with this formula, I'm going to do this first with this. So look at example 8. So let's go back. Don't worry, we're almost done, guys. It says, at the beginning of the summer, the population of hive of bald-based hornets, which are actually wasps. Did you guys know that hornets are wasps? No? Okay. Well, now we know. Is growing at a rate proportional to the population. Okay, underline that. Proportional to the population means this. dy dt equals ky. It's growing proportional to that. Because of this, I can use this formula. Yes, the YDT means that the rate of change or the rate of growth is growing proportional to how much you have. The population is Y and K is just some constant that tells you how fast it's growing. Does that make sense? Okay. From a population of 10 on May 1st, the number of hornets grows to 50 in 30 days. If the growth continues to follow the same model, how many days after May 1st will the population reach 100? Okay, I'm going to do this two ways. And whichever way you like, you always do. I'm going to do it first with this. So I know that the initial was 10. So I'm going to write 10 e to the, let's see, how long did it take? 30 days? 30k equals 50. I'm solving for k first, guys. That 10 is 10 times that. So I need to get rid of it. Divide by 10, divide by 10. 5 equals e to the 30k. Because it took 30 days, guys, for me to get 50. Next, I'm solving for k. ln, ln. If I feels like I'm saying ln. 30k. Not ln DeGeneres, just ln, like natural log. Okay. I'm going to divide by 30. Divide by 30. K equals, and let's see what this number is. I'm gonna store it to the calculator, by the way. Don't bother trying to write this, like don't bother trying to memorize anything. Just let the calculator do the work. So here's my calculator, and I'm just gonna do ln of 5. ln, I'll stop. Divided by 30. There's my k value. They're always gonna be small. Store to alpha k, so I'm gonna overwrite the last one. Or UK, bam. So there's my K, 0.0536, 0.0536 stored into K. Okay, I'm ready. Let's see what the question says. If the growth continues to follow the same model, how many days after May 1st will the population reach 100? Okay, 100 equals 10 e to the KT. I have this, that K is already in calculator. Excuse me. Oh, on the mask. That K is already in the calculator, guys. Divide by 10. Divide by 10. Remember, that 10 was May 1st, which is what they wanted to know from May 1st. So 100 divided by 10 is 10. 10 equals e to the KT. ln again. ln again. And you can already see it's the same stuff over and over. Equals KT, and then just divide by K. And let's see what we get. T equals, so ln of 10 divided by K. So let me get my calculator. ln of 10, close, divided by alpha K. Oh, alpha K. 42.920. So time is approximately 43 days. Okay, you're about to be mind blown. You ready? Guys, You do not have to do it this way. Because of log properties and ln properties, you could choose any base as long as you do it right, and you will get it correct. Did I try? I hope I tried it. I don't remember if I tried it earlier. I'm going to try it right now. You guys ready? Look at this. You could have said, Chav, I know that it does this, so I don't have to do this one. I can choose any base. I could choose any base. So let's see. Let's see if we can just choose it just by reading it. From a population of 10 on May 1st, the number of hornets grows to 50. 10 times what is 50? 5. So I'm going to make up an equation, and I'm going to say this is 10 times 5. And now I need to make it an exponential. So let's see. I need to make sure in how many days? 30. So I'm going to go k times 1 over 30. So I'm going to say k over 30. Or, I'm sorry, I'm going to go t over 30. There we go, not k. K is 1 over 30. I'm going to say y right now. K, in this case, is 1 over 30. Why? Because now notice, if my time is 30, do I get 50? I'm just doing this just to test. If I plug in a 30 in there, 30 divided by 30 is 1. And 10 times 5 is 50. Do I have 50 hornets at 30 days? It works. Let's see if this would have worked for my formula. For what did they want? For 100? I don't know, guys. It could be an epic fail, and maybe I'm lying to you guys. But I hope I'm pretty good at math, guys. So I'm pretty sure this is correct. 100 equals 10 times 5 to the t over 30. Now I'm losing confidence that it's not going to work. It's going to work. It's going to work. Divide by 10, divide by 10. 10 equals 5 to the t over 30. ln, ln. So now I have this. ln of 10 equals t over 30 ln of 5. Divide by ln of 5. So ln of 10 divided by ln of 5. And then multiply by 30. So put the 30 here in the top. And that should be the same. So let's see if it is. I'm going to take my calculator. It better be the same digit per digit. If it's not, I'm a fake. 30 ln of 10. And I'm going to divide by ln of 5. Here's the moment of truth, guys. I'm actually a little nervous. I'm a little nervy, as you guys would say, Generation Zers. Look at that. Digit per digit. Digit per digit. In years past, let me tell you what the calculus students have done in years past. In years past, my calculus students have said, this looks like it could be easier, but it takes more brain power to figure out this exponent. I'm just going to always do this. The y equals y naught e to the kt. That is fine. If you just want to always do this guy, just write that equation and then solve. Cool or not cool? I don't know. Which one do you guys like better, the blue or the red? Oh. All right. All right, guys. Let's come back.